name, and then we need to find the variables, variable 1 and then variable 2. I'm doing this very exaggerated, but this could be A, Z, whatever. And then after the function, you just type the column, okay? And then you click enter and notice that then you have a space because it's Python automatically recognized that you need to leave a space in order to tell them what to do. For example, we can say well, the result is going to be whatever we want. For example, variable 1 multiplied by variable 2, and what the function is going to do. The function, what it's going to do, you need to return something. And what it's going to return, in this case, it's going to turn result. In this case, boom, we can execute this, okay? And how we're going to execute it, we can say function name, okay? That's, we can call it whatever we want, but in this case, we can call it how? We can just say, it's going to pass, we need to pass variable 1 and variable 2. For example, variable 1 is 10, and then comma, let's say that variable 2 is 6. And the result is going to be 60, right? And let's see what I did wrong. Boom, boom. Function name.
The space in variable 2.
Oh, yes, you are right. And then we could call it again. And surprise, we got 60. How or why do we do all this stuff? Well, because sometimes, and it's very common, that instead of define these results over and over, we can just reuse it all the time, okay? And that's the reason. Also, and it's a very common thing to do, is add some kind of comments. And after the function we define with these 3 commas, we can say author Alex Santos, and then date. We can add whatever. For example, today is 24, 2, and what the function does is like this function multiply variable 1 by variable 2 and return result. Okay, something like that, and then we can say what is variable 1, and then we say the density of rock, and then variable 2, what it is, I don't know, a p wave or whatever. Okay, and this is not going to execute, but if we go to our next step, okay, what this really do is we can call the functions help. How? We can say help, and let me remember how did I call this. This is function name. Now we're going to come back and we can say function name, function name, and boom, it says the author is Alex Santos, and this is what it's going to do. All the stuff that we add inside of our a comment section of the function is going to show up here, which is something very nice whenever we are sharing information with other people. Also, another way is like we can call function name, and then we can add the question mark, and at the end, notice that in the bottom of my window show up this window, and is having the same information with a little bit more detail, like where it's located and so on and so forth. But this is something very nice, especially to document all my results, okay? Well, after this brief introduction, I can tell you that you guys, the people who are studying at this moment, are in a very nice time, because there is a lot of data out there in order to make thesis, in order to make a lot of projects. For example, when I studied 15 years ago, it was very hard, especially to find a seismic cube in order to do some thesis. Well, right now, only type in the World Wide Web or the www, you can get all these very nice projects, and that if you are looking to make a thesis, you may contact me, and it will be very nice to do it. Okay. Also, a very nice source of information is the SCG Wiki. Then you can have a tons of well logs, seismic data, and so on and so forth. Another for the people who probably are not on the seismic or in the oil and gas exploration, but maybe are more like a geothermal side, you may have this project that is GVR Open EI, that it has a very nice or large data set about geothermal stuff that you can see, or you can find shape files, gravity files, magnetics, and a lot of very nice sources of information. Okay. Also, for a lot of you who are students and maybe are looking for another way to get money, it is right now it is something called Kaggle. I mean, there is other ones, but one of the most famous source to do open competitions, it's called Kaggle. In Kaggle, it is like you sign up and then you compete with all over the world, and then you can get very nice ranking. And then first you get publicity, because right now, for example, it's not for me. I always present this to the people that, for example, if I receive a CV of someone, I don't care who is this person. For me, it's more important like what these people did. And if I can see the profile of this person in Kaggle, and I can see how good and what he's ranking on Kaggle, it is it says a lot of the people, okay? And especially for the oil and gas, I can tell you that there is two very nice competitions that I would like to highlight. There's other ones, but there are two that it really caught my attention. Oh. The one was about the salt detection. This company, TGS, and this is, oh, sorry, let's start with this. The Los Alamos Laboratory, they publish this data set that, I mean, where you can go to Kaggle right now, Kaggle, then you can put LANL, earthquake prediction, and the idea was to predict some kind of earthquake, and then you can also go to the data, and then you can use this data for your personal or for academic use, basically. And then they have another one called sponsored by TGS, the Salt Identification Challenge, that the people who won, they won $100,000. Okay, and for the previous one, the award was $50,000. That means these are very nice competitions. This is very cool things, and basically you need to focus about you need to use Python. Then you can use R and other languages, but Python is one of the most important. Okay. Then I have another source of code and to learn new things are the GitHub repositories of people. And for the reason I have listed here the GitHub repository of the SEG, as well as the Brandon Hall. He's the leader of something called Agile. And one of my good friends, even that I never met him before, but his name is Johannes Nuwara and Epo something, and they are from Indonesia, and they are very cool because they are organizing very good competitions, and they're showing very good presentations, and it's a very non-academic environment, and they just want to share information to the people, and the people who is listening to me in Spanish, uh, especially in Latin America, well, for the guys in Brazil, you're also welcome, that in the near few weeks, I'm going to start a new series of talks, but it's not going to be, again, talking about Python from the beginning. It's going to be, I'm going to invite you, again, the people who listen to me, and if you have a project that it will be very nice to share with other people, we're going to present this kind of talks. Maybe we can do some kind of live and the people can share their information and also share their codes and using this platform that is called GitHub. Okay, and also this is my personal GitHub that hopefully soon I will start to publish some of my personal work and share it with you guys. And for example, the Johannes work, this he's publishing, for example, this regional and residual anomaly separation using support vector method, I think. And this is from gravity data. And also he have another GitHub that is showing, for example, the compute seismic attributes, especially or based on this Dodge F3 data set, okay? And it's very, very cool, and I highly suggest that you should go and take a look. And now let's go to the practical part, okay? What we're going to do today is we're going to have we're going to plot some well logs. We're going to do a wavelet. It took me some time. I'm going to skip the wedge model part, and I'm going to import some seismic in front of you using Python. And well, let's start. Basically, if we would like to work with Python, what we usually do is we need to import some libraries, okay? And the most common libraries that we import are usually Matplotlib, as I mentioned, NumPy, that is more like to work with arrays, and Pandas, that allows to handle information in a more easy way. Then what we usually do is, okay, we need to import our data from some area, and this is the location of the file inside of my computer. In this case, this is the location, and we're going to import the well F021 that is part of the part of the F3 dataset. Okay, could be whatever. This is a very easy way to import the wells, but you can do it in in several ways. Okay, there are other libraries that are very more helpful for that, but I'm just going to show it to you step by step. Notice also that since we're talking about an LAS file, we need to skip some rows. In this case, again, this is a very simple way to do it, but I'm skipping the rows 35. Why? Because I already see the file, the LAS, and I already know how to import this well. Then what we're going to do is we sometimes, especially in some of the data that we work in geology and geophysics, if we put 0 in our values, it's not good. And for the reason we need to set null values. The null values are sometimes it's set to be 99.29. And what in this line of code, what I'm telling to Python is saying, when the data that I saved all my information in the data variable, in my variable data, when it's equal to this number, I'm setting to be not a number. That's basically what we're doing. Then now let's going to convert our data to a pandas data frame, and we are going to just click here. Okay. And okay, I need to execute this. Okay, okay, I assign mnemonics into my wells because I'm naming here and saying what's the name of each of the columns, and we're going to see the result here. Okay, we already convert our data into into our pandas data frame, and we just can visualize it using call it and say data, and then we can see that right now we have a depth, density, sonic, gamma ray, and so on and so forth. Notice also that we have not numbers, okay? Something that in the past probably we have a 99.25 number. Also using pandas, this is not a pandas talk, but this is a very useful tool that we can select, and we can call data.head, and it was going to show the first 5 rows on my dataset. Some Usair Adam is asking, how do we install the package? We install the package here. We are calling the packages, but you can first, I mean, this is the to import the packages, you need to do it in all of your Python scripts, all the code that you're going to do. Okay. However, if you need to do once, do something pip install, for example, pandas, and then pip install numpy, okay, and so on and so forth. You need to, all the packages that you're going to use, you need to do the same. And the most important is that this is need to be done in a terminal CMD, the command prompt that you usually have in your, in the case of Windows, in a CMD. This is not something that you do in the Jupyter notebook. Okay, you can do it, but I mean that's a different deal. Then, okay, on the same way that I can see the top of my data set right now, I can also show the last files or the last rows. Notice that we can see here the row 96, 79, 78, and so forth, so on and so forth. And also, it is a very nice and a very, very cool feature that is already built in a function that is called describe, that if we just call it, notice that right now I have all my columns, and also I can see how many values do I have, the mean, the standard deviation, the minimum, the maximum, and the other statistics of all my variables, okay? And in as you notice, sometimes I need, since this is a presentation, I'm just going to reduce the number of columns that I'm presenting, and for the reason I'm just going to create a subset, and I'm going to select only let's say 4 or 5. I'm going to select only a subset of values, and I'm going to select depth, density, sonic gamma ray, and effective porosity. This is just because, again, it's just part of that it looks better. And right now, again, I'm not going to go into details about how to plot this, but I can create a very nice and clean oh, I forgot what. Oh. I can just tell to Python that I would like to show all my columns of my data set, and right, notice that it's saying that it's an asterisk, and when it say an asterisk, it means that the cell is thinking, and voila, this is our result. Okay. I can, of course, all this line of code is specifying what color do I want, if I want the title, if I want the thickness of my colors. For example, I can change the color of my plot. It's saying only C equals to, let's say, black. I can just type black as a regular English. This is part of the very easy to talk with Python, because you can type black, or you can type, for example, K, as I will do it later, and in the way you can see the result. Let's wait. Oh, surprise. Okay. Also, instead of type black, it will understand if I just type K. Well, but I'm not going to do it. Well, I can generate a very nice plot. Also, I can generate, for example, if I can, in a very easy way, yeah, I can, for example, plt.plot, and then I can say the data, and then I want, notice that in my data set, my first column is 0, 0 is depth, 1 density, ET is the second one, and for the reason I'm going to call 0, 1, and then I'm going to say I want all the rows in column 1 in the x-axis, and then I'm just going to do and then I want this, and I need to Notice here that the area is a model matplotlib pyplot has no attribute plt, and it's because it needs to be plt.plot, that's the name of the function, and it generates something crazy. Why? Because plot lines, and if we want to get something like to make the dots, I need to call something called a scatter. Okay, in the same way I can change, for example, size equals to, or size of the little dots, we can call it 0.5, or I can also change the color as I mentioned before, let's say red, and I just type red. Okay, and this is a very nice way to also plot our figures. Let's go to our next exercise, and this is going to be something more geophysical related. For example, what about if I want to get the amplitude of our Richter wavelet? And in the Richter wavelet, we need to define the frequency, the wavelet longitude, and also the sample rate. And this is maybe takes some time, maybe you may think that it could take some time, but it is also very, very simple, because I just need to, again, import my modules that help me. Okay, this is the shape that we want to get. Okay, where if in these few minutes that left of the talk, I'm just going to show you how to, if we want to get the wavelet and also the spectrum or the frequency of my wavelet. Okay, and for that we need to, for the first thing is to import our modules, and we need to get, for example, numpy, another parameter, another modules, and in this way, let's define first the let's define. For example, we want a wavelet that have a frequency of 25 hertz, and it has a sample rate of 1 millisecond. And well, you already know how to do this, but boom. The result, it is going to be something like this, okay? Something very nice. For example, right now I can make this figure a little bit larger, and it looks something very, very cool, okay? Again, this may take a little bit of time, but it is very, very nice how to plot these results. And again, with time and patience, you may get very good quality results. And this is something that it is very, very cool to see the final result. And finally, what I'm going to do is, what about if I want to get as the picture before, I would like to get the frequency spectrum of my wavelet. Again, maybe you are going to see a lot of things here, but what I'm doing here, I define the time array, and then the equation that you saw from the Richter wavelet is just here, and then here I'm just calculating the frequency spectrum using another module called SciPy, okay? And then I'm just going to add some interactivity, and I'm just going to show you again as a display way that how the results are very, very cool. Okay, now let's think let it be, and voila. What we have here, we have our wavelet, a Richter wavelet, and also on the right, we have the frequency spectrum of this wavelet. Okay, and in this sense, I also add these widgets that it helps us to manipulate and to, in a very nice way, try to understand what could be the result and how is the, for example, the interaction of all of these variables into my wavelet. For example, if we increase our frequency, our wavelet is going to be shorter, but in frequency it's going to be longer. Okay, now let's take a look. This is something that it could be very cool to think and for the people to understand what is on the university. Notice that when I increase the frequency, okay, our wavelet is very short. And if I make the wavelet a little bit shorter, again, the frequency is going to reduce, but also my wavelet is going to be a little bit like that, okay? And I can manipulate all this, and this is also a very good exercise that for all of you who are willing to take a step further of all this. Finally, again, this is also very cool, and again, the Python and the motivation of all this is because some of you maybe not so don't have access to very expensive software licenses. And what I'm going to show you in the next couple of lines, notice that how many few lines that I'm going to do, and I'm going to show you how you can import Seismic into using Python. Here, as I already mentioned, this is something I import the modules that we're going to get. Again, matplotlib is to plot, numpy is to generate arrays, and here the only thing that you may notice that is different is this one called segyo. That the segyo was a library. Was provided by Equinor, the Norwegian company. Yes, they already make this free for everybody in the world, and they provide this very nice functionality. And what it allows is to already import my seismic into any um, yeah, for anyone. And just okay, this line of code is to import the file, but now also using this function. And what we're calling segyo open the file name. The file name is the location of my file here on my hard drive, and then we're going to save it as S, and we're going to use segyo cube S, and then we're going to call the result as C. Okay, could be C, could be whatever, but C is more like a very easy to understand. And before to plot it, I just want to mention that even that seismic could be something very special for us, but just the seismic is just a bunch of matrices that in the case of inline is like we see all these little squares. We have inlines, crosslines, and time slices. And in this case, we may have, for example, if we would like to plot and to see, for example, we can we can call plt.plot. Okay, in this case, we can, instead of use plot, we need to call amshow. Why amshow? Because it is not, there are not dots as I used before. These are not lines. It's more like an image. And we call C. C is what we call it here. Okay, we can call it in a different way. But C, and then we know that, let's say 150, because I already know the numbers. Okay, 0 or two dots, and then this is the only code that I need in order to plot the seismic. Notice that it's kind of backwards, but also using one of the functions of numpy that allow us to make the transport to rotate an image. Then we can see something that looks more like a seismic. Okay. And I'm just going to add a little bit of the code that I already have here in order to don't spend too much time. But notice here that this is the only code that I need in order to show and to get this kind of results. Like a very professional result of my seismic. As I mentioned before, this could be 150. These are the inlines. Okay, but before that, what about if we say C, that shape, okay, and we can see that our volume has 601 inlines, 481 cross lines, and 251 time slices. And I can say, instead of, let's select all the inlines, and if we would like to cross the cross line, to plot the cross line, let's say 200s, and then I say these are the cross lines in very simple results, we can get something like this. In the same way, we can also plot the time slice and rotate it. Also, for example, Python already using the library of matplotlib, it already have something called another a color bar that is called seismic, and it looks very similar, or is the same kind of color slides that, or the color scale that we usually use on seismic. And as you can see here on the right, we have the 0, we have the maximum and the minimum, and so on and so forth. Okay, and well, this was just a little of the stuff that we can do with Python, especially in Geoscience. Okay, for some of you who are asking like how I did this, I use something called a Jupyter Notebook. However, Google, for all of you who have a Gmail account, you can go to this collaboresearch.google.com, and then you can have something like this that is very similar to the stuff that I have on my Jupyter Notebook. However, the one on Google, all the processing is made on the Google servers. It's not made on in the computer. Also, the data, it need to be storage on the Google machines. I mean, when it say storage, it's not that the Google is looking at it. It's just like you need to locate it there in order to work with it. Also, it's very cool in order to collaborate with other people, since, for example, here I can just click share, and I can share to anyone that I can give the email access, and I can see this information. However, it's not a bad side. Okay, this I just type here, and then everybody can see my notebook. But notice here that it says connect. When I start the presentation, I log in. However, it's not a bad thing, but it's because since Google is giving all this for free, it turned off the computer if you're not using it. For that reason, you can click connect first, and right now it's allocating. That means it's allocating all the space and all the functionalities inside of the Google servers. Then it's connecting, and after a few seconds, it's busy, initializing, and right now we're connected. And right now, when we are connected, notice that here it says that we have Google is giving to us almost 13 gigabytes of RAM and a hard drive of 108 gigabytes in order to make all these computing things. For the reason, especially in my case, I use the Google Colab in order to do my machine learning and deep learning analysis, because it's more suitable for that. Okay. Finally, well, what's next for all of you? Maybe all of you is saying like, well, what else? I'm very excited. Roderick convinced me that I need to learn Python. Well, you need to first take time and learn trial and error, look a lot of all the data or the code that is available for other people in GitHub. That is a very nice source of information. Okay. Also, I highly suggest that you open a LinkedIn profile, because it's a very nice way to promote yourself, and also, especially in this low or very hard environment for all the oil and gas, it is a very nice way to promote yourself, because you can post regularly your findings and the research. Also, a lot of people ask me, well, I would like to learn Go. I hear about Julia, about R. Well, these are other languages that may take some some learning curve. However, the thing is that for me, Python has been very easy and a very good starting point. After you learn Python, that probably you will never, no one already know all Python. It is it's a good way to start, but you also can combine it with, for example, um, you can there are other libraries, for example, Cython. That Cython, it says that is the Python plus or with the speed of C. Okay, and well, it is a lot of combination, but my best suggestion is like you go and take a look of these things. Okay, and finally, for all of you who are listening to me, this is my email. I highly appreciate if you contact me. My GitHub, again, I'm working on it. And also you can contact me through LinkedIn. Also, if you want to have a similar talk in your university, if you are not from the Brazil, the Sergipe University, please contact me and I will be more than welcome to make a presentation for all of you. Okay, and well, now let's talk about some questions. I'm going to, well, tell me, Alex.
Thanks so much, Mr. Paris, for your presentation. It was really amazing. We do not have questions yet in the YouTube. We're here on